In this video, we will learn to count the number of ways objects in a set can be arranged. A set is a well-defined group of objects, or elements. A set could be even numbers less than 12, 2, 4, 6, 8, 10, or the first three letters of the English alphabet, A, B, C. Notice how these are enclosed in brackets. That designates that we have a set. Counting in this section means determining all ways in which the elements of a set can be arranged. One way to count is to list all possible arrangements and then count the number of arrangements. In a simple arrangement, all elements are included and no element appears more than once. We refer to this process as arranging without replacement or without repetition. For example, list and count the ways the elements in the set A, B, C can be arranged without repetition. A good way to start these arrangements is to list the first element in each set, then see what arrangements you can make. So for example, if we have the first element A, we've got the possibilities ABC and ACB. If the first element is B, we have BAC and BCA, and if it's C, we have CAB and CBA. The elements can be arranged in 6 ways. If more than 3 elements are in the set, the procedure becomes more challenging. We may use a tree diagram, which allows each set of new possibilities to branch off from a previous possibility. To make a tree diagram of possible arrangements, first list the choices for putting an item in the first spot. Then, from each choice, list the remaining choices for the second spot, which gives us the first branch. From the end of each branch, make a branch to the remaining choices for the third spot, and then continue the process until there are no remaining choices. To list an arrangement, start from the first slot and follow a branch to its end and record the choices. To count the total number of possible arrangements, count the number of branch ends in the last slot. So here we are asked to make a tree diagram and count the number of ways the elements of the set WXYZ can be arranged without repetition. So here is my tree diagram. Start with W in XYZ in my first slot. Then if I choose W for my first letter, I've got X, Y, and Z as possibilities. If I choose X as my second letter, I've got Y and Z as possibilities. And then if I choose Y, I've only got one more spot. So for each letter, I wind up with 6 possible arrangements. And the list of arrangements is wound up being a little longer than the tree diagram itself. But there are still, if we look at the end of these branches, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 possible arrangements. And that matches up with the 6 arrangements starting with each letter. Another way to determine the number of arrangements is to figure out how many possibilities there are at each junction. Then, assuming the number of possibilities is the same for each option, we can multiply the numbers to find the total number of possible arrangements. In the last element, we first chose one of 4 letters. There were 3 remaining in each case, so we chose one of them, leaving 2. When we chose one of the 2, we are left with only one option for the last letter. 4 times 3 times 2 times 1 is 24 possible arrangements, which is exactly what we saw on the last page. To determine the number of choices for arranging a specified number of items without repetition, first determine the number of slots to be filled, then determine the number of choices for each slot, then multiply the numbers from step 2. For example, a coin is tossed 3 times. How many possible outcomes of heads and tails are there with 3 tosses of the coin? There are 3 tosses and 2 outcomes with each toss, heads or tails. The number of possible outcomes is 2 times 2 times 2, which is 8. Here are the 8 options. We can use the tree diagram to describe this. We've got everything from triple heads to triple tails. One last example. How many 3-digit numbers with no repeated digits can be made from the digits 1, 2, 3, 4, 5, and 6? There are 6 options for digits, and given we cannot repeat a digit after the first digit is chosen, 5 remain, and 4 after the second digit is chosen. The number of non-repeating 3-digit numbers using only 1, 2, 3, 4, 5, and 6 is 6 times 5 times 4, which is 120.